Hi everyone, I'm Kelsey. I'm lead cartographer and designer at Stamen Design, and today I want to talk to you about a tool that we've built to make our bulk cartography really efficient. If you don't know Stamen is a cartography and data viz studio based in San Francisco, and we've been around for over 20 years. Here's a sample of the clients that we've worked with in the past, some still present. There's a lot of variety here, but we work on maps, data visualizations, interfaces, usually some combination of the three. So we have a lot of different types of projects we work on. I'm going to focus on cartography for today, though. So if we are working with a new client on a cartography project, they'll come to us usually and they'll say, first, we need a map for our website or our application. And it seems pretty straightforward. That quickly becomes, we actually need a light map and a dark map because our app is available in different light versions. And then that becomes, what if we had different languages based on the user's location or the preference that they have set on their device? And then what if we could do a different data source in a certain location where that data is better? For example, Southeast Asia, let's use Grab, and elsewhere, let's use OSM. These are all very reasonable things to do, but you can see how quickly one map that they need actually is like dozens of maps with all the permutations of these things together. We call this problem the tesseract. Tesseract is like a four-dimensional shape. And basically, you can see in this diagram by my colleague, Alan McConkey, it goes from something very simple to something pretty complicated. And it can really balloon the number of maps that you end up making for a client project. And we're pretty small at Stamen, so we need to be really efficient in how we work. So how do we tackle this problem? We built something, but I'll explain maybe what we did before we built something first. We manage most of our projects on GitHub, and so we'll work and then share things with the client, like as we're working through a project. And we usually will have a team of at least 2 or 3 cartographers working on a bigger map project like that. And if you know, like editing the same file, several people editing the same file introduces a lot of merge conflicts. It's hard to unspin the web and figure out what actually your PR is meant to do versus someone else's. It leads to inconsistencies, and it's like a little hard to break up work when you're all editing the same file at the same time. And then thinking about how these problems are really magnified when you have like dozens of maps that you're creating for a specific project. We did not want to do that. We wanted to be able to scale and have it all work together pretty well, efficiently, to create a cohesive set of maps that work together. And so we created this tool a few years ago now. I might call it the build system, the style builder. The official name is MapGL Style Build. It's, you can see it there if you visit us on GitHub or check out that QR code. So this tool is public, open source, so anyone could pick it up and use it. You can import a style you've already created. And when I say style here, I mean like a style sheet. And we support, well, I think it's render agnostic, basically, but we usually use MapLibre or Mapbox, depending on the use case. So you could take a map you already have and bring it into our system. And it will break it down into templates, which is the core of the system. So I could tell you all of this, or I could show you. I think showing is probably better. We'll take a variant here. So this is a type of template. We have a map called Toner that's black and white that people tend to be familiar with. So a couple years ago, we recreated Toner and terrain and some other maps using our build system to use vector data. So this is an example of Toner. Toner here you can see in the variant template, we have all of the variables that we'll use there listed at the top. I'll get into those in a second. At the bottom, you have stuff you would expect to see in a style sheet, so like the name of the style, your default extent, what the sources are, and then on the right side, you have the list of layers that are in your style. And then if I want to go look at something specific, I want to go see the national park layer. I'll go and find that file. That's a layer template for the national parks. And you'll see there that looks pretty similar to what a layer looks like in a style JSON, which is the output of this system. And if I want to know more about the variables in that file, I can go and look at those. In this case, we're looking at colors, and they're actually not colors, they're patterns, which are listed here in my variable template file. And you can see the name of the icon there at the bottom, halftone sprite and halftone 2. Those are the sprites we're using for this particular map. So that's like a lot of technical stuff, but what does this like actually let us do? Why is this useful? Technically speaking, we're able to work quickly, efficiently with a team and really scale up to create sometimes hundreds of maps. The main idea here is to create several styles that work together. So if I make a change to the kind of base style, the core style here, in this example, that'd be like a reference base map we might start with. Those changes can propagate down to the other styles too. So like, let's say we decided we want to make all of our roads a little bit wider in all of the maps. I can make the change once and it will happen for all of the styles, which is really nice. Previously, you'd have to do all of that manually, and that would take forever. I can't even think about doing it that way now. That would be awful. You could swap out color palettes here. You could have like different level of detail for different variants. So like a data viz base map, we might want fewer features on it for it to be a little simpler because data will probably be on top of the base map that we have. Or another example would be like a transit map where you might want to add more features and really emphasize them. We can do all of that easily with this system. I picked this example like 2 months ago and it feels very timely, but we can easily differentiate between different styles with like one line change. So here, like the default political view, this is here data, not OSM. On the left is showing the boundaries disputed and otherwise in Kashmir. And then on the right side, we have the India political view. This particular client has to serve certain boundaries in certain places. And we can easily change that here with our variable that allows us to say for the India style, go get this filter. For the rest of the world style, go use this filter instead. And that makes it a lot easier. You can see we manage like 20 different political views for them. But otherwise, again, that would be hard to do. And that's like the kind of thing you don't want human error introduced into when it's like they're legally required to provide these exact boundaries. Better when a system can do it for you. You can easily swap out different data sources. So this particular client has different data sources in different locations. So Grab they use in Southeast Asia, they use open data in most places, and they also have the option to use here. So I can easily say for this version, this variant, use open data, for this one, use here. And it's that simple. Like I said before, avoiding inconsistencies, this is probably my favorite part of the system. So if I want to change the size of primary link roads in this example across my entire style, that would happen in 12 different places. And so if I wanted to experiment with the sizing, I could do it here once and it would make that change in all these other places. And I can confidently know that they will all be the same width at every zoom level where I write them here in this expression. From a process perspective, we're really collaborative at Stamen, so this is a great way for us to be able to work together. And we have a lot of tooling that we've developed over the years, so this system works really well with those. We'll take like a layer here. This on the left is a layer template, and on the right is that same layer in your output style JSON. You can see they look pretty similar, so any cartographers that come in who have worked with this type of this format, which most of them have, that Mapbox with MapLibre, that's the same language that we're using here. We just inject like a little bit of code into it to make things a little bit easier, but it's pretty easy for people to pick up, which is really nice. So you don't have to teach them a whole new system. Like most of it is pretty intuitive. It's easy for us to review work without conflicts. So like maybe I'm working on a color palette and my colleague Alan is working on admin boundaries. There might be a little overlap between those things, but they won't conflict with each other because we're editing different files, which is really nice. Before it was like such a headache to untangle all of the conflicts that were happening. So this is much easier. And then we have a larger suite of tools that this system works well with. I will not go into all of them because that would be a whole separate talk. But I'll show you a couple that we use often, especially right now. We're working on like a navigation map for one of our clients, and I can make changes locally to the map and then see it in our route simulator and see how it actually looks with some of the interface of a navigation map on top of it. So like when I'm going along a route, how the map will change the pitch and will zoom in and out, how the puck will look on the map. All of these things I can see in real time while I'm making updates. So you're not flying as blind as you would be otherwise. The tool we would use for this otherwise would be Mapperature, which is our viewer, which is also open source and publicly available, where you can make changes locally and have Mapperature running locally too. So here I've changed that building outline for toner to lime green for some reason, and you could see it right there next to it. I like the original better, but we can experiment and have it all happen really quickly. And I guess I've already given myself away here, but we have used this tool for client work. A couple of clients here, I can't name them specifically, but to give you examples, it can be really complicated, like, 5 parts of the Tesseract, so like different color palettes for different devices, which comes with all of their own questions, lots of different data sources, political views, languages. That's one client, so that build system was really helpful there. Another would be a little simpler, like 3 color palettes, 2 types of maps. All the maps have a couple languages. That's a pretty simple one, but it's still really helpful for that. A client I can talk about, this is Amazon Location Service, or AWS. I made this slide like a month ago, and it was true then that we managed 212 styles for them, but actually now it's 282 styles because we added some. I won't list them all here, but yeah, if you had to edit all of those manually, that would suck. That would take a long time. So this is a much easier system to work with. And so that is how we handle the Tesseract at Stamen. It's, like I said, public, open source, so if you want to experiment with it, please do. And if you have a project where we could be helpful in getting started or designing some maps for you, please let us know. You can find me, Kelsey at stamen.com, or we're around. I have some other colleagues here too. Yeah, thank you.